Good morning. In this session, we are going to see a topic on the effectiveness in NTU method. The NTU method is applicable for analysis of heat exchanger if outlet temperature are not known. In such cases, it is difficult to find Q for heat transfer of since the exit temperature is not known. Thus, the heat exchanger can be designed by the LMT method when inlet and outlet temperature are known, but when it is required to determine the inlet or exit temperature for particular heat exchanger, the analysis is more easily performed by using a method based on NTU methods, number transfer unit methods. The NTU method requires three parameters, that is a heat capacity ratio, effectiveness, and number of transfer units. The heat capacity ratio is defined as the ratio of minimum heat capacity rate to maximum heat capacity rate. The effectiveness is defined as the ratio of actual heat transfer to maximum possible heat transfer. The NTU method is a measure of size of heat exchanger as a value of or constant for a follow and flow conditions. The LMT method may be applied to design problems for which the fluid flow rates and inlet temperatures as well as the desired outlet temperature are prescribed. If the LMTD method is used in performance calculation for which the both outlet temperatures must be determined from the knowledge of the inlet temperatures, the solution procedure is iterative. The heat exchanger effectiveness is a formula of effectiveness, and the maximum possible heat rate is as per the C minimum into T1 minus the hot fluid minus cold fluid. The formula for NTU is equal to UA by C minimum. It is a heat exchanger relations formula. These formulas can be taken from the HMT data book. The compact heat exchanger, it is analyzed based on the NTU method. Convection coefficients have been determined for selected heat exchangers by KLN, and the data have been obtained by manufacturers of many other core configurations. In this problem, we can take a properties from a HMD data book from the tables, and the analyze the NTU method is a formula is epsilon is equal to 1 exponential minus NTU into 1 minus CR divided by 1 minus CR exponential NTU into 1 minus CR. NTU is equal to UA by C minimum. In this problem, we can find out a Reynolds number and Nusselt number and the local heat transfer coefficient, average heat transfer coefficient, mass of rate flow, and the area of the water side temperature effectiveness. Finally, the value of number of heat transfer unit is 3.62. All the data can be taken from the data books. In this problem, use a fluid spheres and solid spheres to enhance the performance of concentric tube, the water glycol heat exchanger. We know that the flow rates and inlet temperature of water and glycol in counterflow heat exchanger, desired glycol outlet temperature, the heat exchanger diameter and overall heat transfer coefficient with and without spherical inserts. We need to find out the required length without spheres, second one required length with the sphere, and the final one is the reduction in fouling and pump power associated with using the spheres. The properties can be taken from the HMD data book. The value is 52.4 degrees Celsius. Thank you.